Welcome everyone to another code review here, and increasingly C is amazing. We got this, maybe not, and why after 20 years I'm not the most impressed by the Linux kernel anymore. So the other days Yamaha MU90R previous videos and ULX3 FPGA stuff and so on, and so I thought the other day, because I obviously don't usually have a MIDI sound card like Sound Blaster or whatever in my workstation, I thought as like this thing does have serial support. Also, yeah, ironically, Linux, advanced Linux sound architecture, no support for MIDI over serial, at least just in the kernel. Anyway, thought I'd take a serial cable here and use a serial port for some testing. And I was surprised that my workstation, because my workstation board has a serial port. Of course, usually you don't necessarily have those anymore on your latest and greatest PC boards. And as you see here, TTY S1, 0, and so TTY S0 works, but I wondered why the heck do I have here TTY S0 to 4, TTY obviously. And so yeah, 4 serial ports. I was like, is this a BIOS bug? Why do I have here 4 ports? What I expected, so what do I expect? I expect a modern operating system like Linux, like not some old-fashioned Unix, like statically allocated and precompiled Unix stuff from the 70s. A modern OS I expect to only show and offer devices that actually freaking work. And if you try to use the other ones, it's like, yeah, input-output error. Thank you very much. And I poked a little bit further. First I was like, yeah, YOLO, whatever. But so I looked and like, is this a BIOS bug? I decoded here some stuff. Also, this might show serial numbers. So I patched this away already. So COM DMI decodes, like, yeah, only one COM port, and here also TTY S is like, yeah, only, as you see the kernel, also only like registers one serial console. And it's like, yeah, what the heck is even going on there? Can we quickly patch that? And turns out, no, we can't. This is a config option. It's like, yeah, 2021, you get a config option. This is like, you can't make this up. A recurring theme, I wish I could sit here saying everything is amazing, but these are the things. So wherever I look, like LVM rates, like, yeah, some things not amazing, or other config options like doesn't boot, crashes in previous videos. But after 30 years of reworking, they still have a maximum number of serial ports, default 4. It's like, yeah, thank you very much. And why do I make a video? I just want to present here some findings as I find them. If I reiterate this in a year or two, I might have already forgot this or get some details wrong. So I just want to point some stuff out that where I really wonder, after 30 years, industry-leading, most installed server operating or embedded operating system. And I thought, yeah, can we quickly modify this? I even thought, like, yeah, do I change this to 2 or something? But looking at the code here, that is in 8250. Also, fun fact, 8250 is what was in the original IBM PC. That was a 8086 later, since I think the probably 28680 or so. We have a 1600, 650 or something. Do we probably 16 have it here? No, 16C554 something that has a FIFO. The original one doesn't have a FIFO. The later one have a 16 entry first in, first out buffer for improved performance and such less interrupts and less lost characters. Anyway, if we look into this, we see the true amazingness of the C language of, yeah, defining also, yeah, you have a config define, of course. You need a define UART number for, I don't know, less typing something. Why not use code review? It's like, yeah, other people not amazed by my patches, like, yeah, YOLO, whatever, we don't apply this, but yeah, defining a UART number thing when you already have a config serial. It's like, yeah, okay, fine, whatever. Also, he's also defined port RSA mixes. Yeah. Anyway, so of course C being C, here's some fine statically sized C array, because it's certainly how we do this in 2021. And this is also so you can't even, also, yeah, so how could you change this? What I would expect, so how to do this better, I would expect this to dynamically register drivers with a driver core SK object there, like all the other, like, or not, I shouldn't say all, like probably there are other old-fashioned statically allocated sized buffer things in the Linux kernel all over the place, probably, but most drivers nowadays, of course, dynamically register that. You don't have the sound cards, like 8 sound cards that are not there, or 8 Ethernet cards, or 24, just pulling here some random numbers, serial ATA, IDE, SCSI drives. What I would expect here is, instead of having here some hard-coded array of struct UART port, have like most other, probably 96% or most drivers in Linux kernel dynamically register that, but I certainly don't rewrite this, because as I presented here, the consequence of this is a little bit confusing. Of like, why do I have 4 ports? Can I solder some more cables there on my logic board? It's like, yeah, I can't. They're not there, yeah, why? I really wonder. They have here, ironically, some overrides, so number UART that is passed here dynamically on the, well, passed dynamically on boot uptime for unsigned int module parameter, or boot time of specifying this with 8250 dot number UARTs or something, either fully modular on modulo time or boot up. But yeah, of course, this is also probably, so how I, maybe a tiny little bit of improvement, maybe I should patch that here to 2, and not to have here 4 non-working or 3 non-working, but only 1 or 2. Makes this a tiny little bit less confusing. I'm certainly not refactoring that, but yeah, this is why we probably should in general not use C for that. What is the problem? Of course, the problem, first of all, in 1990, when Linus Torvalds started this, life was, of course, simpler, just like make some statically allocated array there, statically sized array. But the problem is, of course, dynamically you would need to lock this, think more than one CPU processor or core, then you need to lock this, allocate memory. Of course, everything is more difficult in a kernel, especially written in C. But in general, we of course have here register device things, somewhere of drivers like Ethernet, network, Ethernet, and grab register or something. Registering devices of, by the way, we could probably find this easier with grabbing for Ethernet name, registering stuff. Also, yeah, various forms of string, copy, and whatnot, depending on the driver author. Although maybe Ethernet not the very best example, maybe we should take something less outdated, like maybe this one here. And also best without WI is stuff of register. Of course, here this is register net device, but I would expect something of register serial stuff as this, like, yeah. But this is their style, and their quality, also here character of IRQ names. Seriously, IRQ names with maximum 10 characters. Yeah, you see, totally amazing stuff. Recurring theme here, leave me in the comments below what you think. But in my opinion, it's a little bit attention to detail of having their devices that are not functional. And ironically, probably most of the other devices that are there, fun fact, how many are this? Find of type file word count, 951 devices, of course, many virtual, like just the TTYs alone are, of course, TTY. Also some symlinks, although actually symlinks are not in there, because with total symlinks, of course, more. Yeah, it's just, also what TTY? Why do we have 300 something, just TTY2 maybe. Do we have them twice for what? Others is one. Oh, okay. Anyway, just TTY virtual TTY terminal type things alone, apparently 300 something. Also like that. Yeah, 325. So out of a total of 900 whatever that was. So yeah, 1/3 TTYs, because dynamically allocating is hard. Anyway, leave in the comments below. Of course, in general, not the very biggest deal. Obviously, just some data points, examples, code review, stuff that could have been long improved. And also, ironically, devices that most logic boards don't even have anymore. So yeah, fun fact, try poking your TTY 0 to 3 on your latest and greatest gaming board, which anyway, that's it for this video. I hope you learned something. Otherwise, except you probably could also learn quite a bit scrolling the latest and greatest security or updates here. And fun fact, just the other day I learned there were of course some security mitigations here in iSCSI, I think. Also TTY, just when we speak about this, right? Clean up legacy leftovers, like statically allocated serial drivers, right? And TTY line description of, yeah. Anyway, what was the other one? Teach and TTY line description about new cookie. I think this was iSCSI, and so there are a couple of vulnerabilities. I think even like remote to privilege escalation. I think all of them, maybe 3 in iSCSI. It's like, yeah, because buffer handling in C and stuff in manual, they got this apparently also endure attribute limited by page sizes. Anyway, one thing with more, I hope it's usual, or we can actually use this one. I hacked up a small MIDI with my previous RISC-V firmware from the ULX3S of playing back here MIDI, of course, just some Sunday hobby stuff and filling some code. I painfully had to remember what a not amazing API the handling of TTY, this tilde type stuff, is in Unix systems, and this is rather crazy. I just googled there because actually, fun fact, I've written some of very few serial plug and play. There's actually some serial plug and play protocol implemented by some mices and modems and stuff of back in the day. Actually, I've written some code for that. There was, not even sure if the Linux kernel had that, but X386 back in the day had some code. There's some serial PNP code from me, which is rather hacky because of the nature of pulling down there some lines and stuff. You would even need to Google the stuff. But yeah, despite having written that, a decade ago I had to re-Google the stuff, so copy and pasted here some TTY stuff together. And this kind of stuff here is rather just like, yeah, clear parity bit and stop bit and stuff. And I have to say, this kind of APIs really suck, in my opinion, this fixed structure type of stuff. And why do I even look into this? For me, of course, a little bit of vintage MIDI stuff of like, yeah, previous video didn't have such luxury back in the day, and now I can, and enjoying some vintage music and games. But then if you look into this, because obviously long-term working towards some unified nano microkernel firmware stuff, and I'm also thinking how to do this better, right? For some things are easy, like actually block devices of here, like block devices, right? Failing stuff, previous videos. That is of course easy, just open, seek, read, write, except that's the easy part. The not as easy part is sending custom commands like think smart stuff. and also we are not in focus. Can we focus? Smart and discard, for example, trim and similar stuff. That is, of course, a little bit tricky to do super nice. But with this kind of stuff, I really wonder how to modernize such APIs, because for microkernel, this is, of course, if we implement everything from scratch in more amazing code, Rust or C or D or Zig or Swift or whatever, I really wonder how to design API much more clean, amazing, scalable, readable than this old-fashioned flag stuff here of TTY structures. And well, not to start, also serial port, as it relatively simple, right? Open, read, write, close obviously, and of course high performance like I/O U-ring nowadays. Probably could throw the data with slip I/O ring through serial parallel ports or SCSI, serial ATA, NVMe. But I wonder how to modernize APIs in a way that makes dealing with such kind of stuff like controlling parity bits, rarely used on serial ports, like to stop bits or other like this echo eraser TTY stuff of like, yeah, if you want to just communicate raw data on a serial port, you don't need this. So basically you only want this kind of stuff if you have a real TTY there of terminal kind of interpretation of interrupt, quit and stuff, of control Z and control C and stuff. And yeah, because these are the stuff, open, read, write, serial ID SCSI is even the nice thing to do. This kind of stuff are, in my opinion, the rather more ugly details, writing your own kernels, like, yeah, fun fact, implementing all this kind of stuff. Yeah, I really wonder, probably, of course, the easy thing is just implementing raw serial and parallel without all this hacky Unix compatibility bits, and do that later somehow. But maybe I do some prototyping in my opinion, it doesn't even need to be high performance. I mean, you could do some stuff like this of course, having a per device, you could have like plan 9, like per device, per virtual pseudo device, file system entries, like everything is a file, and have this kind of stuff, writing this of parity bits, like having Linux, like controlling all this kind of stuff with kind of virtual device. But this is, of course, rather messy, not high performance, and not differently not nice to write code with. I wonder even if, given that we wouldn't have this kind of driver stuff in a microkernel, because you guessed it, increasingly getting a fan of microkernel and more address-based separated stuff. Given that we don't have such kind of stuff in a microkernel, we have only the bare minimum of memory allocation, process management, interrupt and timer handling, and so on. And we would have serial drivers in user space, so we could do more fancy parsing, obviously not in C, without string talk and stuff. If we use a more secure language that doesn't crash left and right, I wonder if using some kind of protocol buffer or even JSON to parse kind of like IOCTL parity stuff, maybe that would actually be more amazing than this good old-fashioned hard-coded bit stuff in C headers of stuff. Just some crazy ideas, might be similar, annoying, but leave in the comments below. And this is also what I'm increasingly want to get into, prototyping some modern stuff. And this is also why, for me, it's like just moving to BSD. Well, yeah, they're similar, the same, probably allocated. Even the Minix kernel, Minix 3, lots of, even more, like the Minix are surprisingly, although that is microkernel, much larger amount of more legacy, hard-coded, statically sized stuff. It's like, yeah, again, not making it, just making it a microkernel, not necessarily much more amazing as seen in Minix 3. But anyway, leave in the comments below what ideas and experience you have. Have you worked certainly with serial ports and embedded devices? What are your findings? What is your take? Oh, I deleted that. Anyway, let's see. John Conrad starting having issues with connecting wasn't two monitors, but sure it's a kernel Mesa. It's like, yeah, hard to tell which driver. Anyway, or is it your Wayland compositor? Anyway, that's it for this video. Only wanted to share this funny anecdotal details here. I hope you learned something, and don't forget to like and subscribe for the next videos and live streams of this fun stuff to come.